everyone. So we're going to move on to the next part, which is all about Ohm's law. So we already talked about the basics of circuits, how to draw a circuit, how to tell if a circuit is working or if it's not going to end up working. We've also used some basic ideas about finding the resistance of objects and finding current through objects. Now we're going to actually take a lot of that and start doing some calculation and some analysis of circuits. So Ohm was a scientist who actually came up with a procedure to vary the voltage through objects and record the current that was through it. And he realized that no matter what the object was, the relationship between voltage and current was the same, and that it was dependent on the object itself. So when he graphed it, he ended up getting this relationship, a very linear, direct relationship. And what he found was that if he took the slope of this line, he would end up getting the resistance. So this leads to Ohm's law, which is his equation, V equals IR, that the voltage across a resistor or across an object is equal to its current through the object times its resistance. From here, we can actually see that a lot of the things that we know make sense. As you increase the resistance, you end up decreasing the current because they have an inverse relationship. If you increase the voltage, you increase the current through an object. So a lot of the stuff that we already know actually applies with this equation. So we'll do some practice. So pause the video, work itself, and we'll go over in a second. All right, so here we have the current and the resistance. So they want the voltage or potential difference. So V equals IR, plug our numbers in, and we get 12 volts. Easy peasy. Here's the next one. Pause the video, work itself, and we'll go over in a second. All right, once again, we use Ohm's law, V equals IR, plug our numbers in, and we get our answer of 0.015 amps. As you could tell, using Ohm's law equation is very, very basic. The important thing though is that it will have immense applications. All right, here's the next set. Pause the video, work itself, and we'll go over in a second. All right, so this one's a little bit trickier. So part A says, what is the current through the circuit? Now, we could use Ohm's law, but if you look, or if we attempted to use Ohm's law, even though we have the voltage, we do not have the resistance. In fact, we're finding the resistance in part B. So it's very clear that we're going to use Ohm's law here. So instead, we have to use another equation. So we're going to go and use our equation, I equals Q over T. Now here's the thing. Q is measured in coulombs. None of these numbers have coulombs. So what I actually have to do is I look at the number of electrons. The electrons carry the charge. Every electron has a charge of 1.6 times 10 to the negative 19 coulombs. So what I can do is I can multiply the number of electrons and the charge per electron to find out what the total charge is. So I do that, I plug it in for Q, divide it by the 8 seconds, and I get that the total current through the circuit ends up being 10 amps. Now that I have the current, I can use Ohm's law, plug it in with the voltage, and get the resistance. So when a 12 volt battery is across this resistor, it's going to result in 10 amps of current flowing through it. All right, here's the next step. Pause the video, work stuff, we'll go over a second. All right, so remember when you see a graph, you have three options: read the graph, slope the graph, area the graph. You have to remember to do one of those three. Now, in this specific case, like I said, you probably could get away with using Ohm's law, but you really want to avoid using equations. You want to try and remember to do slope and area because there's a good chance that while it may work for some cases, plugging the graph values into an equation will not get you the correct answer. So here, we go back to what I said before about the slope being equal to the resistance. So if we take the slope of this line, we pick 2 points, doesn't matter which two. I'll do 20 and 0. Plug it in, and I get that the resistance value is 25 ohms. All right. All right. So we just want to make sure that we don't use any of these data points that were, above and below the line. Here's the last question. Pause video works up. I'll go over in a second. All right, so we could start doing the same thing because once again they want resistance. So I can take the slope of it, but this time when I start plugging the numbers in, you'll notice that there's current on the y-axis and voltage on the x-axis. So when I do my slope, I'll end up getting zero point 0.5 amps over volts. Before it was volts over amps. So in order for me to get the resistance, I have to take the inverse of this and get 2 ohms. Again, something that they could do, it's a little curveball to make it a little bit trickier by flipping the axes. All right, and that's it for that. Uh, like I said, for the most part, Ohm's law is very basic by itself. It's what we're going to end up doing with it in the next part that becomes extremely important. In fact, Ohm's law is very similar to Newton's second law, F net equals ma, where it was a very basic by itself, but what was important was how you can use it to answer other questions. So, Ohm's law, right now, we just worked on how to deal with a simple circuit where we have a battery and a single resistor. In the next video, we're going to actually talk about looking at multiple resistors within the same circuit and see how to deal with that. Once again, if you have any questions, feel free to let me know. Otherwise, good luck and have a great day.